Um, right now in your infrastructure, you have idle compute. It's not because there's no work to do, it's because your infrastructure was designed for a world that doesn't exist anymore. We're talking static allocation, ticket queues, and one engineer as the bottleneck. Every day that continues, your hardware is not producing anything. It's costing you money. Um, so that's what we built Orion to fix. We built Orion because we ran infrastructure teams ourselves and lived the problem firsthand in visual effects. I'm Tony Como. I'm COO of Juno Innovations. With me, we have Alex Hatfield, our founder and CEO, who's going to be driving our live demo in a bit. And we also have Dan Walters, who's our CPO, who's lurking in our live chat. He's going to be answering some questions. So feel free to put in any questions that you have as we go along. Here's how the hour is going to work. We're going to discuss the problem and have a fully live demo for you guys, and then end with some Q&A. So don't worry about writing notes. We're going to be recording this and sending a link out after the webinar is over. So let's party. So we're going to go over a couple of things today. The problem, why you're spending a lot of money on GPU or any type of compute, our platform, what Orion actually is. Alex is going to be demoing everything on a live cluster and real infrastructure. It's not going to be recorded, and we're going to end up with some Q&A. So let's start rolling. 10 to 15%. That's the average GPU utilization across enterprise clusters. Not a lot, really. The other 85 to 90% is idle, and idle compute has a price tag. All this hardware you're financing but not using, it's costing you a lot of money. So if you really think about it, hardware isn't the problem. It's you already own that capacity. It's actually the orchestration that's your bottleneck. Most of you guys probably are already fully aware of the complexities of the world. This isn't just a GPU efficiency story. There are three major things converging right now that don't care about your budget cycle. Everybody knows about the VMware. Broadcom acquired them, raised prices. Migration decisions are now out of your control. They're out of your budget cycle. Right now the GPU is going nuts. We have AI that is, driving the world as it is today. So basically, we're stuck with, how can I get hardware? Is it available? Or can I just reuse what I already have? But most of us are underutilizing the hardware that we currently have. Therefore, a bottleneck isn't the silicon, it's your orchestration. And then lastly, things are just too complex. We have over 3 clouds out there: VMs, containers, bare metal, air gapped, on no air gapped. It's no single pane of glass, no unified scheduling. It's just tickets and waiting. These 3 things are happening right now, and this is why the timing matters. So right now, there's 2 kinds of organizations. We have the legacy trap, 24 to 48 hours of workstation provisioning, 10 to 15% GPU or compute utilization, 1 engineer as a bottleneck, and renewal costs are doubling. Then we have this newer wave that we're able to be a part of with the infrastructure elite. Here, you're able to have 60-second self-provisioning. You're able to have 2 to 4 more capacity with existing hardware, customer hosted and no vendor lock-in, and you actually have predictable controlled costs. 70% of B2B buying decisions are made to avoid loss, not to capture any gain, but to avoid the loss. If your team is sitting in the legacy trap, that's not a feature gap. That's a competitive liability. Let me show you how we close it. Orion is the unified compute plane. We are a supervisor layer that sits above infrastructure. Every GPU, CPU, RAM, VM, cloud instance becomes one shared request-driven pool. Orion can dynamically slice and schedule your GPU compute, your bin packing, automatic reallocation, and allows you to have 0 idle cycles. We also offer self-service workload delivery. Researchers, users, developers can just request and launch, no ticket, no engineer needed. And then what's great about our platform is you can deploy anywhere: cloud, on-prem, air gap. Customize. You can custom your host wherever you want, and your data stays with you. Alex is going to show you exactly what this looks like on a live cluster soon. So 4 things Alex is going to be going over. We're going to run through our dashboard, our self-service workstation launch, compute slicing, and we're going to scale down and we're going to show you the scale down economics. So Alex, let's take it away.
All right. So thank you so much, Tony. We're going to go through and actually have some fun doing this. So first thing we're going to kind of go over is I'm going to pull over. We're going to get the presentation out of the way. And the first thing we're going to talk about is a cloud deployment. So one of the biggest things that enterprise struggle with early on, and even smaller based companies is I need to be able to do some kind of computing. And the biggest thing that they want to be able to do is I want to be able to have access to the cloud. And that means that you could use it for maybe 100% cloud-based companies, or you just want to have it for bursting, or you just want to be able to have access and play around with it. Totally fine. Now, something really great about this is that I can go through and we can install Juno on an EKS cluster on AWS. That's what we have here. I'm going to make it a little bigger so you can actually see it. And the beautiful thing about what Orion does in this context is we can install it one way on the cloud, and we'll see here in a moment that we have the exact same setup on-prem. That's the vision, that's the goal. And then on top of that, we want to be able to present these compute resources back to the end users so it's extraordinarily consumable. And that means that just an average person that's not super technical can have access to incredible software with insane hardware backing it up. So the first thing we're going to talk about here is this is an AWS cluster, EKS, running in Ohio. And we're going to start with an already pre-warmed cluster. This one already has, this is actually a development cluster that we run some work on. And yes, we're running it on the bleeding edge on the development cluster, but we're pretty confident it'll work fine. We already have 5 servers in this that's running a bunch of other stuff right now, but we're going to demo kind of just what the auto scaling looks like in a real cluster. Now, this server right here already has the workload running on it. So in this case, I already have Blender up and running. And I'm going to pull this off to the side, and we'll show what the scaling looks like in a second. So already requested it, ready to start working. I can just connect immediately to the instance itself, right? So I can set it up, and here's Blender. Now, the great thing about this is if I open the system up and I do an MVTop, you'll be able to see that I can go through and I already have load on the GPU itself. Now, something really great about what Juno does is Juno's not a VDI solution. It's a workload solution. And what that means is that it can run pretty much anything. And as an example of that is we just so happen to be running something called Selkies, which is the backend engine that we use for our example VDI solution called Helios. So what I'm going to do is I'm going to kind of, make it a little bit faster. We're going to make it turbo. We're going to use some CPU encoding as well as actually use the GPU to help decode a lot of this stuff. And that'll make the system super responsive at range. So again, I'm in South Florida, this is in Ohio, and I'm able to use this system, which is great. I'm gonna be able to move this. You'll see that it's actually rendering live off the GPU. So as I move this around, you'll be able to see that the GPU's got load on it, which is fantastic. And what I'm gonna do is I'm gonna show putting some actual rendering on the system. So we're gonna go ahead and render this scene, render an animation, and we're just gonna let this run in the background. Now you can see here that this is what Juno kind of helps you do, right? Is we have a GPU that's running, we're doing some rendering, it just did it, and now the trough is loading in, right? So we have a trough of like, okay, now the CPU is gonna go off and load the scene, and now the GPU is gonna spike back up. And it's really those troughs is what we're looking to go after here, right? So the question really is, how do we get that utilization up even more? We wanna keep as few troughs as possible. Now this is where Juno really starts to shine. I can jump over back to my workload manager and I can start instantly slicing this GPU without actually needing to do really anything on the end user's experience. So I can go to my catalog here and I can go, let's slice this one more time. And then in a second, you'll see it pops up provisions, and then it'll almost immediately say connect once it's done provisioning. And I can open up the events list here. I can see that everything is here. The container image is scheduled, and I can connect almost immediately to that system. Now, what makes this so great is that now I can go through and open this up. I'm going to turn on my turbo again. And I'm going to say, okay, let me see my NVTop. Now, you'll see here the GPU already has load on it, right? So that means that it's sharing the same GPU that it had before. This is called time slicing. And I can open up Blender one more time. And we're going to be able to see that I can load a scene and further slice that GPU and put even more load on it. So we're going to open the same scene again. Take a second to load up, and we're going to start rendering again. Okay. Now, the great thing about this is if I jump back over, we have Catherine, we have Alan. I'm going to jump back over to Alan here, and you'll see at the GPU troughs here that have been running for a while, these are much longer now. So what we're doing is we're fully saturating that GPU even longer than before. Now, some questions that we get all the time is what about VRAM contention? What about stuff like that? That's definitely a thing depending on which mode you're running in. So we do not actually do the slicing ourselves. What we do is we use compatible NVIDIA GPU operators or AMD or Intel and other brands. But what we do is we allow you to be able to schedule, slice, and put more workload on it. So that means you can support MIG, vGPU, anything of that kind of way to be able to consume those resources. And that's what Juno helps orchestrate. So you can see here we're just sitting at 100% utilization because we're fully saturating this GPU at this point. So let's go ahead and jump over here. Now we're going to show that what I'm going to do is I'm actually going to delete and shut these resources down. So by deleting these, I can then pull over my server list, which is over here. And you'll see almost immediately that the server's flashing up here. This one's flashing. We're going to see this one here flash in a second. And just by deleting those workloads, you're going to see that in a second, it takes about 30 to 90 seconds for this number right here to go from a 0 to a 1. And what that means is it's actually this one up here. I totally missed which number it was. So this one up here, that's basically Juno saying, okay, cool, there's no need for this server. All the work's done. And what it's doing is it's shutting down the EC2 right now. So there's a big benefit to this. If you're on AWS or you're on any kind of cloud, you're paying for servers that you launch when you're using them. It's a pay by the drip kind of methodology, which means that already just by having this kind of auto scalability built in, you're going to save a ton on your cloud bill. And then when you compound that with the capability to be able to fully saturate and run a ton of workloads on those servers, you're able to even save more. So if you mix the scaling with the density, the cloud build numbers that you'll see later on, such as like 70% or whatever it may be on cloud spend, it's mainly due to the fact that we do this. So you're mixing the auto scaling with the actual act of being able to put as many workloads as possible on a server. So we're going to stop in the cloud. Let's go to something else, right? We're going to go to the exact same setup or a very similar setup, but we're going to do it on-prem. So I pulled this over. This is an on-prem cluster that I have inside of my house. Now we do have, for example, in this workload, we do have a DGX Spark. So I'm sure that some of you guys have heard of the DGX series from NVIDIA. It's running the Grace Blackwell chips. A lot of people are using it for AI inferencing, which is great. But something that Juno really lets you do is it lets you use compute for pretty much anything, right? So what this allows me to be able to do, for example, is this is an ARM-based DGX Spark with the latest GPU technology, unified RAM, all that kind of stuff as well. And what I can do is I can just launch something as a very basic workload, such as just a Chromium browser. And in this case, I'm going to open up and connect to it. And I'm just going to play a couple seconds of this video so you can see it. But the incredible thing about this is that I have an embedded application that's able to stream directly off of some compute in a remote network. Now let me break down what that means. For example, if you have some sort of sensitive data that you need to have access to, or you need to be able to do management into a cluster or a compute cluster, or for some of us who have done M&E work, visual effects is a big one, you have typically a content network where your frames are being rendered and all that kind of stuff, and you want to be able to do dailies so you can open that content and stream it. You have to create split VPNs, you have to do all this kind of stuff to be able to do that. Instead, what you can do is something like this. You can use something like either a Spark or just a random machine you have around the studio, and you can open it up and stream a browser directly off of it, so you don't need to expand your security footprint. You can actually keep it much tighter. Juno basically acts as a portal or a connection broker into that environment. So in this case, what I'm going to do is I'm going to go ahead and play. We're going to see it really quick run. It's a couple seconds. We're not going to watch the whole scene, but just a couple seconds so you can see what it does.
Who the hell is that?
Maverick to range control. Entering point Alpha. Confirm green range.
Maverick, range control. Green range is confirmed. I don't see an event scheduled for you, sir.
Well, I'm going anyway.
Nice.
Setting time to target, 2 minutes, 15 seconds.
2:15, that's impossible.
File attack point. Maverick's inbound.
All right, so I'm going to stop it there because we're going to kind of do something a little similar to what we're doing in this scene, right? We're flying into this canyon. We're going to flip the fighter jet around. We're going to do some crazy stuff. So we're going to do something very similar with Juno here. We're going to do some things that people have never seen Juno do before, and it's going to be really great. So first off, This is an embedded browser ready to stream. We can have access to secure networks. We can stream content. We can use an ARM-based system with a GB10 attack to it with an actual Grace Blackwell chip on it. And this is just streaming a browser. Now, let's pretend that we are also some sort of development company and we want to have access to this kind of work. I can then go through and connect to, for example, a VS Code embedded setup that will allow me to develop directly onto that system. Now, if I had multiple DGX Sparks or any other kind of server, if you yank the power plug on one of them, this will migrate over automatically for you and it'll relaunch the session so you can connect to it. Imagine the world where you can have a cluster set up for your developers, for your users to be able to build directly on this incredible amount of compute by simply giving them a zero client with zero latency to be able to connect and start developing on this platform. This basically acts as the environment for your entire company to function. We're talking about developing for the gov space. We're talking about developing for AI inferencing. We're talking about for visual effects studios that might need to build pipelines. We're talking about even companies that are building websites. This is the platform that can do that. You can embed this. Now, let's go ahead and move on to the next thing. We're going to get even crazier here. If we wanted to have, for example, I have my own data center and I want to be able to grant access to be able to SSH to a server that I am maintaining. Normally, you'd have some kind of jump host. With Juno, why? You don't really need that. Instead, I can launch an ephemeral terminal directly into the system. I can log into it using the actual federated logins from Juno. Make sure I got my password right. And then I can go through and connect to my computer that I'm on right now. So we're going to do 60.25. And this is the computer that I'm streaming from that I just logged into. And now I can do some work on it if I need to. So Juno then acts as essentially a portal for you to be able to manage your infrastructure. We have some customers right now where they actually use Juno as strictly a way to manage infrastructure in their data center entirely by using ephemeral terminals just like this, or using browsers that are launched into Juno to be able to connect to the backend services to make sure they work. We're not talking about just running workloads on Juno. We're talking about granting access, managing infrastructure, and it becoming the core backbone of how you actually manage your compute. That's what we're talking about. That includes storage, that includes networking, that includes access, everything. Now let's jump to something else. Let's say you're a data scientist or you're some sort of biotech person that needs to run a Jupyter notebook. We've got you covered. I can leave this and I can connect to my Jupyter notebook, which is running on my DGX Spark. We're going through and using that setup. And now my data scientists can go through and run their Jupyter notebooks on top of this. Completely embedded, no screen sharing. This is an actual web app that's run with no input latency, which is pretty incredible. Now, the next thing we're going to jump to is, it is a DGX Spark. We are talking NVIDIA. Biggest thing that everybody's talking about right now is AI inferencing. How do we run these kinds of tasks? So I'm going to connect to OpenWebUI. Now, the great thing about this is Juno can also run VLLM, Ollama, anything on top of that, and that's actually being hosted and managed by Juno on that DGX Spark. And now I can talk to the system once the model warms up. Hello. Take a second to spool up, and it'll respond. There we go. And now let's go even crazier. Instead of using this as a way to do RAG or getting data, what if we actually want to do automation? I can then jump over to, for example, N8N and run full workloads on this system. Hello. And then on top of that, that'll run the VLLM chain, and then we'll be able to start executing some sort of command on top of that and build workflows into this. Now, this is the world that Juno is built for. This is what we're focusing on. This is what Juno does. We were born in M&E. We were focused in that world. And now we're realizing very quickly the amount of applications that you can manage here. What we've shown you today is I can do AI inferencing. I can do Jupyter notebooks for training. I can also do ephemeral terminals. I can do embedded Google Chrome browsers. I can also do VS Code. And that's really the infrastructure that we're talking about. This is why Juno solves a core compute problem. This is what makes us so incredibly special. So I'm going to hand this back to Tony to sum everything up.
Whoa. I think you forgot something.
Oh, yeah. Okay.
Remember the big thing.
Yeah. Hang on. One second. Gotta move this back. Okay, so one other thing. This is the last thing that we're going to kind of talk about for a second, and kind of going down that route, mainly because we've never been able to solve that problem. Obviously, you can see here, I didn't click on this one. Now, in this case, I'm just going to show you really quick a huge change that's happened to Juno. Juno now functions as a valid hypervisor alternative that can run virtual machines alongside existing container workflows. So for example, all of these are containers. This is a full-featured virtual machine. If I open this up, I can go down here, click on the virtual machine, and I can do standard things such as start, stop, pause, restart, migrate, all those kinds of things to other servers. And then on top of that, you also have the full capability to create golden images, which you can install and set up and then store inside of Juno to be able to create replicas. Now, something incredible about this is what Juno is known for is its end user focused ephemeral workload workflow. So in that case, I can come over to my catalog here and I can just click launch Windows and create. Now, if you click on any one of these, whether it's Signal, Jupyter Notebooks, they're all the exact same UI. They all run exactly the same way. That means that when virtual machines are requested, they are per user, they are built to be able to be launched exactly the way that everything else that you've done in Juno works. Now, something that I'm going to kind of talk about is a lot of people use Juno for either VDI or some sort of, accessing for high fidelity connections to systems. Now, Juno itself does not provide that kind of technology. We don't do that. But we've always struggled with acting as a connection broker. Now, what I can tell you is that finally, I'm very, very proud to say this, is now if I click on this connect button, you can now actually click and connect to things over TCP and raw UDP connections by simply clicking this button and copying whatever connection information is required. So for example, that means you don't need to use Selkies or Chasm VNC that we've provided before. Instead, you can install things such as HP Anywhere. You can run RustDesk, all these other things as well, and then expose them through a port like this, and then direct connect to them via Juno as a connection broker. So let's go ahead and see what that looks like. I'm going to open RustDesk. I already have my port here. We're going to walk through the workflow. I can copy the port and paste it up here, which is already there. And we're going to go through and actually connect to this system. Now, this is a little different. This is a surprise that we have for you guys. If you notice when I move the start menu, yes, this VM does actually have a GPU attached to it. Now, caveat to this. You cannot do time slicing or GPU slicing without a vGPU license or some sort of slicing technology that's provided from NVIDIA with virtual machines. So you can't slice with Windows right now. We'll try to figure it out as time goes on. But you can do raw, direct GPU pass-through through this system, which is pretty incredible. So I'm going to go through and play a really quick video, and then we'll kind of, summarize some of the stuff that's here. All right, so for those of you who know Juno, you know that we've always liked How to Train Your Dragon. We always do that for our demos, but I think showing off just a YouTube video is kind of meh. It's not really that great. We do it all the time, so I think probably something we should do is talk about Unreal, okay? Now, something great about this is, yes, this is a direct GPU pass-through virtual machine ready to go with Windows running Unreal inside of Juno as a full-featured VM. Pretty incredible. So now what I can do is I can click my play button, I can connect directly to the system, and I can move around and use Unreal directly in the system. So this is pretty great. We can do this now. This is a massive improvement from everything that we've had before. You have connection brokering, you have Windows support, you have Unreal support, you have GPU pass-through set up. You also have multiple kinds of connection brokering solutions that you can use now. We just do port forward out. So essentially you can use HP Anywhere, you can use Omnissa, you can use pretty much anything that you want and then create a virtual machine image that can then be stored and pushed out to be able to be used as a replication that you can run for your workloads themselves. So what I'm going to do is I'm going to go ahead and shut this down, and I'm going to finally hand it over to Tony. Let me go ahead and pull him back over. And let's go ahead, Tony.
That's pretty cool, Alex. I didn't think Unreal ran that fast. So that's great. For those of you that are interested in running KubeVirt, we are running a beta right now, so feel free to email us. Again, I will send contact information out after this webinar is over. So that's really, really cool. So to kind of recap, Alex went over the self-service provisioning in 60 seconds. We went over some time slicing, confirmed workloads, VMs running inside the same cluster, all that fun stuff, no hypervisor. That's pretty nice. So we have to kind of also follow up with our case study that we have. Redmond 3D, R3D Studios, they have deployed us. Before they were stuck in the 10 to 15% GPU bust like everybody else was, but after they deployed us, they saw a 78% cloud reduction cost on AWS. They've been able to utilize 92% of their GPUs as an average, not a peak, and they've reduced their infrastructure engineer need from 5 to 2 and just redeployed those people to other projects that are more valuable. And last but not least, they've had 0 critical failures. Donald Strubler, co-founder of R3D Studios, he actually told us that Juno just works for us. R3D wouldn't exist without Juno. That's pretty great. Like for them to be running us as their backbone, that's incredible. So we're at the Q&A section of the chat. We have about 20 minutes, give or take. So if anybody wants to put any chats in, let's go for it. If not, I know Alex has some prepared questions of general stuff that we've asked before, that we get asked before.
Yeah, so definitely post questions in the chat. I know we're a little bit on a delay between when you see us and when the questions will come through. So if we're a little slow to respond, that's why. Now, what I want to do is I do have some pretty standard questions that I get pretty regularly. So, you know, is the basically the 10 to 15% or the 92%, wherever we're getting those numbers for the GPU utilization, is that the average or is that just peak? Typically it's around, you know, average that we can fully saturate, because the reason those numbers are calculated that way is because when we're not using the instance, it usually deletes itself on the cloud and it goes away. So when the instance is up and running, it's actually doing work. So that's a benefit to Juno, is if you're not actually shutting it down, then those numbers will drop down to 0, and then that's when your averages go down. So the benefit to what Juno is doing is the reason why those numbers are so high is because we don't leave static compute sitting around, right? The other thing too is another question we get all the time is, do we do the slicing for the GPUs? No, we don't do the slicing. We are an NVIDIA Inception program partner, so we have the full blessing from NVIDIA and everything that they do. But essentially what Juno does is we take consumed pre-sliced resources and we go through and issue that out to the cluster. So we do all of the orchestrating. And then something else that we get a lot of questions from is basically, are we air gapped? That's a really big one. Because of M&E and visual effects, a lot of that stuff's air gapped, so that means that we can run in air gapped environments. That does also mean that, for example, government work and stuff like that, we're very, very well attached to. We can deploy pretty much anywhere for that because that's what happened for day one for us. And yeah, that's kind of the gist of the normal questions that we get. I definitely, you know, please ask questions in the chat if you have any. I know we just went through a ton of stuff, so it might be a little bit of a, you know, a little bit of a shock of some of the stuff that we've got going on. So, but yeah, go ahead and post some questions, and then we'll go from there.
Disruptive would it be to switch to that if you have like your own hypervisor or off VMware?
The underlying technology is KubeVirt, and KubeVirt has a migration path for VMware, so that works out pretty well. So importing and running VMware VM images is pretty easy for us. We've tested it twice, went great. It's still, the KubeVirt is still in beta for us. It's planning on general availability, I think at the end of the month or end of next month. I don't know. I have to remember when it's going out. But yeah, it's not that painful to be able to do it. There's some networking stuff that you have to change. The underlying networking technology is using something called Multis. So you just have to make sure that some of the networking configurations, such as VLANs, that needs to be carried over. But the actual active running a VM inside of Juno that's from VMware is not a problem. That's super easy.
Cool. And how complicated it is to install Juno?
It's easy. So if I go to, this is pretty neat. I'm going to pull this over here. So let me go to grab the Juno Innovation site, which I highly recommend everybody goes to. If you want to test out Juno, we have a a community-driven setup for this. So the first thing you're going to do is you're going to go to our site, junoinnovations.com, and then when you scroll down, you'll see here that it says copy this code below and install it on any Linux server. So if you've ever wanted to try out Juno and just see what it does, you can go through and SSH to a remote Linux server and then just run this command, and it will install and set up Juno for you. It walks you through a whole wizard. Really, really easy. And then once you're done running that command, you can then click next steps, which will then take you to the whole process of going through all the authentication, the configuration. It's really, really easy to do. Yeah, it's actually a pretty nice setup. So I can show you really quickly what it looks like. So I can go here. We'll just copy this command, run it, and here you go. You fill out this form, and then Juno will be installed on this server. And then as you join new servers to it, you can make a pretty large Juno cluster very, very quickly. So pretty neat how that works.
Well, kind of wrapping this up, obviously there's a huge gap between 10 and 50% of utilization versus the R3D 92%. The gap between those numbers is your opportunity. It's sitting in your infrastructure right now. So it's kind of, like every month is, a month without action. You're financing your hardware and it didn't produce anything. So the question isn't really where the gap is, whether the gap exists. It's really like, what are you going to do with it? How are you going to close it? So best way to evaluate, as Alex said, we do have a community edition, which is free, full platform, self-hosted. You're allowed to deploy up to 2 workloads at the same time, and run it locally on a small dev cluster, whatever you want. Alex showed you the KubeVirt stuff. If you guys are interested in that, we could totally sign up for the beta and get that deployed to you soon before our grand release. We also have a proof of value, which is generally about 30 days. It's going to be your cluster, your workload, your hardware, everything that's yours, your environment, and you get to set up however you want. You're going to measure the delta, and we can kind of discuss the savings and positive stuff that you've learned from that. And then obviously you can just book us. Alex and I are willing to chat. We can talk about your environment, see how Orion could and help improve what you currently have deployed. And like I said, we're going to send a recording and all of the links that we listed here and a email follow-ups as soon as the webinar has been uploaded back to you.